Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2017, time zone 1 in May, so that is question number 10. A classic question relating to the topic 4, bonding and structure, a really important topic that tests for a lot of the points every year, no matter paper 1 or paper 2. Let's see, they're asking, which two atoms form the most polar bond? So here comes to the asking of the concept relating to a concept called polarity. Students should realize that polarity exists within covalent bond, in which how polarity comes from is because of the difference of electronegativity between the two bonding elements when they form a covalent bond within each other, right? Or you can say an uneven sharing of electrons is resulted, and so leading to the polarity. And the source and the reason why such an event or such a phenomenon occurs is because of a difference of electronegativity. So which simply implies that if the difference of electronegativity is going to be large, or in this case the largest, then the polarity will be most. That means with the highest degree of polarity, right? So in simply apply to our periodic table is that the two elements should be mostly separated, because as we know, electronegativity increase just like this direction, right? What I'm now pointing to the right hand side most and to the uppermost position, right? Excluding the consideration of noble gas. That means in the world, the most electronegative element will be in the group 17, the topmost position, fluorine, and the first runner-up, which is going to be oxygen. And then the second runner-up, that is going to be nitrogen, right? So those are the three most electronegative elements, right? So that's why if we are going to choose the most polar bond, we better choose the distance or the separation between the two elements across this periodic table, the largest. The separation, that is, the higher the degree of the polarity of the bond, that is, right? So that's why with this understanding in mind, that we should easily observe again from the choices. The first one, CNF, seems like a really good choice because fluorine is a really high electronegativity element, while carbon is not so high, right? Next one, chlorine and carbon, right? So if you compare these two, you can see, right? Fluorine and carbon, which is having a large difference comparing to chlorine than carbon, because fluorine is the most greedy element in the world, right? So that means it is going to be really high in terms of electronegativity. But then carbon is in the reference position, so if we choose between fluorine and chlorine, fluorine will be better in terms of having the bigger electronegativity difference with carbon, right? But if we continue to look for the second one, in choice C, we see silicon and fluorine, right? In which you can see silicon is even having a relatively lower electronegativity than carbon. So which means in the lower case position, silicon is in the lower position. And compare with fluorine and chlorine, fluorine is having the higher the position, right? So if we consider the difference of the two, the biggest difference should be coming from the highest with the lowest. So in this case, which means fluorine and silicon, right? So in other words, they are having the greatest separation across this direction, right? As mentioned before, more going to the top right hand corners, the higher the electronegativity. So in other words, more to the bottom left hand corner, the lower the electronegativity it is. So that's why in terms of this case, fluorine and silicon, which is going to be having the greatest difference of electronegativity than any other choices. So that's why obviously the answer is going to be C. So that means the logic is, for the lower case, we choose the lowest electronegativity. For the upper case, we choose the greatest electronegativity. Then they will be creating the biggest difference in electronegativities. So that's why the bond is going to be most polar.